Academy. Science Academy is a free resource for students, teachers, and parents to explore all kinds of scientific subjects through experiments and activities that you can do at home. I'm meteorologist Kat Taylor, and today's episode we're learning about how hail forms. Plan your experiment somewhere you don't mind getting wet. We're in our kitchen here in the studio. You will need a few unopened bottles of purified water without additives like electrolytes or minerals. This was a brand I could find pretty quickly. And an empty water bottle around the same size filled with tap water. You'll also need a few ice cubes and an easy access to a freezer, as well as a plate or a pan. This experiment is sensitive, so you may have to try a few times. Place 2 of the unopened bottles of water and the tap water in the freezer and let them sit undisturbed for 2 to 2.5 hours. Occasionally check back to see if the tap water has frozen. If it has and the other bottles have not, that means the pure water is super cooled. The exact time needed to cool the water depends on the temperature of the freezer and the size of the water bottle you chose. If the water in both of your bottles is frozen, you need to melt them and start again, but check the bottles a little bit sooner. Another way to super cool your water bottles is to make an ice bath. You're going to fill your tub about halfway up with ice, put just enough water to where it gets to the top of the ice cubes, add about 2 cups of rock salt, make sure it gets down to 17 degrees Fahrenheit, and then wait for about 10 to 20 minutes to super cool your water. It's going to depend on the size of the water bottle you chose. Take one of the water bottles very carefully out of the freezer and tap it on the counter. And watch it freeze very slowly. Water needs either nuclei, particles like dust, salt, and smoke, or a nucleation site. By disturbing the water, you're triggering the water molecules to rapidly align and form crystals. Put some ice into your pie pan or your plate and very carefully remove your next bottle of water from the freezer or from the ice bath. And again, very carefully open the lid and slowly pour the water onto the ice and watch a tower form. So what does supercooled water and hailstones have in common? Let's take a look. Frozen water droplets are swept up by updrafts into a thunderstorm. Supercooled water exists in several layers of the storm. Supercooled water droplets touch the frozen droplets and they freeze together. The baby hailstone will tumble around in the storm, and each time a hailstone gets swept up by the updraft, another layer of ice forms. Eventually, the weight of the hailstone is more than the force of the updrafts, so the hailstone falls. Next time you see a hailstone, split it open and you'll see rings from the layers of supercooled water deposited. We'll talk more about hailstones and updrafts in the next episode of Science Academy. If you would like detailed instructions on how to complete this experiment, go to ktiv.com and search Science Academy.